Welcome to Walk About the Galaxy, the Four Seasons Astronomy podcast. You can interpret that as you wish. Where the science is universal, the opinions are personal, and the hosts are not holograms. Just want to get that out there.
That's important to get out there?
It is, absolutely.
Okay.
I just want to put any rumors to rest. We are Strange Charm atop the Astroquarks, also known as Josh Caldwell, Distracted Person.
Addie Dove. Sorry.
And Jim Cooney.
Coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, where you can see our wild gesticulations and eye rolling. Our stumpers today are propulsional.
Propulsional.
I'm doing two
I could believe
separate
that
stumpers.
was a word.
Propulsional?
Yeah. I bet it's not, but I could believe it.
It's not.
Oh, man.
Why would you believe that one?
I don't know. Like relating to propulsion.
That's all of them where I've done that is relating to whatever the word
I know,
is.
but that one,
Welcome to the show, Jim.
that one kind of rolls off the tongue nicely.
When I would say things
That's because it sounds like proportional,
It does sound like proportional.
Which is
Maybe
the
that's
word.
why.
which is a word.
Yeah. Which means relating to proportions.
Saying.
Addie,
Hello.
chemical
Here.
or ion drive?
Chemical or ion drive?
Like chemical rocket? Mix some hydrogen and oxygen
Yeah.
or whatever, liquid
I like
methane.
ion drives.
Okay.
I think they're pretty cool.
Explain how they work.
You can't. I'm
can't?
just kidding.
Inexplicable.
So an example of a
magic.
spacecraft with an ion drive was like Smart 1. That was one of the first ones, I think, right? It was a European.
Smart one? Okay, I'm not
It was a
fine.
little
Take
tiny
your word for it.
European
Never heard of
mission that had a little ion propulsion. So basically, the idea of ion propulsion is that there's some sort of catalyst inside the engine that's often just like a solid. Sometimes it's like a solid thing, actually, now. Anyway, it spits out little ions from the rocket thrusters, but it's like a very slow effect, but it builds up over time.
Yeah.
And so it's a good, like, long-term propulsive method. It's not going to get you initially anywhere fast.
Yeah. Do they have, all of those have some sort of, they have like an electric field that accelerates the ions and they pop out the back and they have very little mass, but a decent velocity.
Yeah.
But it just
So,
gives
like,
you
for
this
small
like
spacecraft,
constant
it's- yeah.
low thrust.
Yeah. But so because it's a constant acceleration,
You just keep going
build
and
up some
going and going
speed
and going and
you go,
going and
whoop.
going.
Yeah.
Yeah. Okay.
They're pretty fun. And they're like relatively new. There's a lot of cool potential applications for some CubeSats with ion type
Yeah,
engines
okay.
because big thing with CubeSats is it's like really hard to have chemical propulsive engines, especially like CubeSats that are launching from the ISS or anything. You can't have any of that.
Yeah.
So, but you could have like a little solid block of something that eventually that you work on ionizing.
Right. Yeah.
That's like stable until you start ionizing it when it's
Until you-
off station, and then it's this little propulsive thing.
Yeah. And it sounds cool. Like ion drive sounds
Yeah.
cooler than chemical.
Yeah, it
Yeah.
does.
Sounds futuristic and everything.
Does.
Yeah.
But if you took a rocket, if you're like, okay, you're in space making a space movie and you have a rocket there and it's got ion, it's like, fire up the ion drive. You're going to see it like go, it's just going to be, it's
Josh
accelerating.
is very, very slowly moving his hands.
accelerating at 10 to the minus whatever G's or something like that. where it's
Accelerate
like
10 minutes, and your hands are now an inch further.
moving like a centimeter per second,
Yes.
maybe. Yeah. But come back in a month and you're hauling ass. Whereas the chemical drive doesn't sound very futuristic, but it's awesome to look at. It's very cool.
Yeah.
Jim, you have a similar sort of thematic choice.
Oh, it's called Deep Space One. Sorry.
That's what I thought it was.
Yeah.
Okay. Deep Space One. What did you say?
Smart One. I thought that was one too.
Okay. I don't know about that
I'm
one.
gonna Google this a second.
Your choice has
neat.
also got a
Your
sort of
smart one.
dramatic
Yeah.
and a slow and steady. Nuclear reaction plate
Yes.
or solar sail.
Solar sail. Oh, yeah. I got to go with nuclear. Nuclear, dude. That's awesome. It's where you like you take a nuclear bomb and you blow it up behind the spacecraft, and then it propels it forward. So that's
That
a really
is very
radical
quick.
acceleration. That's
Very
not-
different than an ion.
Yeah,
That's right.
yeah. Not very good for people on board, as the acceleration will be rather extreme. But if you want to
Is
get
it
going
really?
fast,
I mean, is there?
well, it would depend on how big your spacecraft is, of course.
Right.
But
So
I
this was originally proposed, way back in the early days of, the nuclear age in the 50s or 60s.
Yeah.
Where you would have a big spaceship, some giant, massive shield at the back, and you'd sort of drop a bomb periodically.
As one does.
Sort of like ploop bombs, like rabbit droppings out the back of your spaceship that
Some rabbit droppings can be explosive.
Nuclear detonations.
Yeah. Yeah, and I mean, so that's one of the. I mean, there aren't too many ways to kind of get the kind of acceleration you need to get to another star system, right? So solar sails are awesome, but they're not going to get you very well to another star system, because as soon as you're far away from our sun, then you don't have much oomph anymore.
Except for that breakthrough initiative where they're going to build a giant laser
sail
and
thing,
blast.
Right. That's awesome.
I said solar sail. Maybe I should have said light sail, but that probably wouldn't have changed your.
So what I want to do is I want to do the nuclear one on a really tiny, like.
You want to drop a nuclear bomb behind a CubeSat.
Behind a CubeSat. That could really get
it going.
Like a frying pan there, and then drop the nuclear.
Yeah.
Just get it going.
Yes, okay.
Yeah.
Right.
I like it. Smart One was, in fact, a mission.
Okay.
Then it was by the ESA, and it was testing solar electric propulsion.
Oh, okay.
It was at the moon.
Okay.
It was like a secondary payload.
Also.
Thing, and it was a ride share.
All right.
It was cool.
Today we'll take a look inside Mars. Forming exomoons and inside a supernova explosion. But first, this episode of Walkabout the Galaxy is brought to you by the Killing Field. If your manifold metric is leaky and you're in the market for a new vector field, then the Killing Field may be just what you need. With a vanishing Lie derivative of the metric with respect to the field, the Killing Field makes sure your flow generates a symmetry and make sure that distances are not distorted in the direction of the killing vector. Known for, quote, the little group, end quote, of generators of rotations and the boost generators in the Minkowski space, Wilhelm Killing's Killing Field will give you a twist and a boost in a metric-preserving way. The Killing Field. Don't be evil.
I always thought that was a very kind of an unfortunate name for a
smart guy, apparently. Yeah.
I'm terrified right now.
The Killing Field.
Yeah.
Wilhelm Killing, 19th century.
Like Keeling or something, maybe?
I don't think so. My German pronunciation is better than rudimentary, but it's certainly not expert. But I think Killing. It's maybe a little bit of an E sound on that first
scary
thing.
sounding though, so that's
unfortunately, like if you Google Killing Field, it's just only thing that shows up is the Cambodia stuff.
Oh, really?
Yeah.
Yeah.
I mean, not the only thing. If you scroll down far enough, but the first page of Google.
That's unfortunate.
Yeah.
It's unfortunate that that's a thing.
Yeah.
But Wilhelm Killing was a 19th century mathematician who did a lot of things that this astroquark does not understand.
Sure.
Mm-hmm. One of which is the Killing Field, but they sponsored the show.
Nice.
Don't be evil.
Google.
Yeah.
Oh, I didn't know that.
Yeah, that's their motto.
Yeah. Related to the upcoming trivia of this episode is some nerd news.
Okay.
We've mentioned these in passing before, but I'm now at the point where I'm sort of getting excited about two new movie adaptations. Jim, you were mentioning these, I think, on your trivia recently that had me completely flummoxed.
Sorry.
Oh, yeah.
One of which is Dune, which is coming out.
Finally.
Did either of you see the David Lean Dune 1984?
Yeah.
The movie. Yeah. There was like a miniseries thing too.
There was also a miniseries on the Sci-Fi Network.
Yeah, I've seen the movie.
Yeah. I did not see the miniseries, but the movie from the 80s. I remember it, loving it back then, but I don't,
I have a special memory for that because it was, I think, technically the first actual date with the woman who ended up marrying.
Oh.
And at the time,
you took her to Dune and she still married you.
That's true, because
That's pretty impressive.
Little did I know at that time, she had zero interest in science fiction. Even if that had really been a really, really good science fiction movie, she would not have liked it. So that's coming up, and the Foundation adaptation from Asimov's Foundation series is coming up as a series on TV in some streaming format.
Yeah, that one perplexes me. I'm very interested in it. His Foundation is obviously one of the great science fiction book series of all time.
Foundational.
It is foundational.
Foundational, I would almost believe that's a word pertaining to foundation.
Pertaining to a foundation. Pertaining to propulsion should be proportional. I bet you
Listen, dude, I've been doing that for 5 years.
Yeah, have you been
and you're the
listening
one
to
who's
our
been
podcast?
giving me a hard time saying that's not a word.
Right, because they're not words, but this one is I bet it's a word.
Propulsional.
Proportional.
But your logic is just the same logic that I've used for every single one.
No, that wasn't really my logic for why it's a word. I agree that is the same logic for the anyway. We're going to look it up later. And
those things are coming up. Looking forward to that. You're not sure how they're going to translate foundation from page.
Yeah, because foundation is this epic thing that takes place over, hundreds, thousands of years, and so it seems to me like it's challenging.
Yes.
To film or make it into a.
Because your characters are always changing.
Yeah, your characters are different in a lot of, and I don't know. It's like. It's not a lot of action and stuff. It's more like
that's right. There's
politics and empire building kind of thing. Yeah, I mean it's awesome, but it seems difficult. If they do it well, it could be great.
Yeah, I should reread it. Well, it'll be different than the books.
There is a patent that is for the original patent application for combined propulsional and directional control device for hydrofoil aircraft.
There you go.
So it has been used in a thing once.
All right. Propulsional.
All right, I don't care what you guys are doing for the rest of the show. I'm going to find my Scrabble app and find out if it's good. That's all I care about.
Could you even make that?
It would be like you could do prop, and then you could turn prop into propulsion, and then you could add AL to that.
But the Scrabble dictionaries have every word that's 15 letters or less because it's possible.
Okay.
Cool.
All right. It's not necessarily possible for every 15-letter word to go in there. It has to be constructible from smaller sets.
No.
Do you know what else happened this week in Nerd News?
Letter, like spaces in between.
Oh,
the only things that aren't possible are like things that would contain more than 3 Z's or something. So that
I see. Yeah. Okay. Yeah. All right. What'd you say, Addie?
I said, did you know there's other stuff that happened in Nerd News this week?
Nerd News. What happened?
Blue Origin. Launched their rocket.
I remember that.
The space news.
Space news. Sorry, that's space news.
This is an astronomy podcast and
not a Scrabble podcast.
Not a Scrabble podcast.
Sometimes it is. That's fine. Yeah, Blue Origin launched.
Right.
Yay!
Their first launch with people. So 4 people: the oldest person, the youngest person, and the richest person to ever go in space, and some other guy.
And the richest person's also Rich Brother.
Right.
Wally Funk flew. Most of my Twitter feed was mostly just excited for her.
That was awesome.
She was so awesome.
Yeah.
To watch.
So that was nice. And the launch, everything was picture perfect. I was mysteriously interviewed by the following 3 media outlets.
Why is this mysterious?
It's mysterious for the following reasons. Because I live in Florida.
Oh, yeah.
But I was interviewed by a radio station in New Zealand.
Oh.
A TV station in North Carolina.
Yep.
And then somebody else somewhere in the United States.
Yeah. Yeah. I don't know.
Some online thing.
I did an online stream.
But was nobody exciting. In Orlando.
I was interviewed by somebody in Orlando.
Oh.
I give you the national one.
You cornered
I gave you the national
one. I had
one.
New Zealand.
That's true.
New Zealand called and they wanted to know if I would be keen to speak with them about it. And I said I'd be very keen.
So maybe some of our listeners in New Zealand heard you. Saw you.
Highly unlikely, but it's possible.
They could find it, I'm sure.
I think it was like 6 a.m. in New Zealand when I was speaking to them on a morning radio show. It was a very odd time.
Wouldn't it be? I don't know what time.
I was surprised at the time he told me it was when he called me. Anyway, time zones are a thing. So that flight went.
It went.
As we have seen these flights go before, and it did just as they are supposed to do, which is 10 and 11 minutes, and you're done.
Their next flight, hopefully. I have a payload on it.
Yeah, that's exciting. We're not allowed to say when that is.
No.
but it's the next one.
I think it's the next one. Yeah.
Yeah.
Unless
We're
there's
pretty sure it's the
unless
next
there's a
one.
surprise one in between.
There may be one in between.
I did see something that said Blue was going to fly 2 more human flights this year.
Yeah.
Which I find hard to believe on this time frame, but they might do it.
I mean,
if they got them queued up, just do it.
I've been surprised at how slowly they've been going. It doesn't really, the rocket comes down
step by step, ferociously.
Yeah. It's like drive the truck over to it, tip it over, give it a once over, fill it up the tank, wheel it back out there. As far as I can tell, I don't see why they couldn't do it every week or 2.
Yeah. That's the plan eventually.
Yeah. So, great.
Cool.
Sciencey stuff. We have 3 things at least.
Yeah. There's some updates from Mars.
Yeah, let's hear about Mars.
Well, so there's some initial updates that it's just, I think Ingenuity flew again, and it flew further this time. And they're going to start
the
helicopter Ingenuity. Yep.
No longer exciting me.
No?
Once it flew a couple times, I'm like, it was like proof of concept. It worked. It was awesome.
Yeah, but it's gone pretty far.
Pretty far now.
Yeah.
It can go out of the range, I think, of being in contact with Percy and then come back.
It's boring me.
You know what? You're boring me.
Yeah.
It's not true. And then Percy is about to drill pretty soon and cache its first set of samples. So one of the big goals for Perseverance is to squirrel away in some little containers some rocks from Mars, which turns out they have some.
Right.
But some specific rocks it's going to pick. It's like, I want this rock to go back to Earth someday in the future.
And I'm going to put it in a tube.
And then I'm going to tuck it in my belly or somewhere.
Right.
So it's going to do, and then at some point, so it's going to start doing that as it's going on its traverses. It's going to collect these little tubes. Yeah. And then at some point, it will drop those tubes. It's like geocaching. It's going to drop those little tubes, and then some intrepid other robotic explorer in the future is going to come pick up the tubes.
Unless some muggle comes along and steals it.
I know. Wouldn't that be sad?
Yeah, that would stink if. Yeah. So I hope they make it so they can find it, but not just out in the open.
I mean, it's probably out in the open because it's Mars and there's nobody else there.
Oh, that's true.
Yeah. So it's pretty safe. Well, that we know of.
But we also have news from Insight.
But yeah, there's some good insight. I love the name of that one. Into Mars.
That one is an acronym too, though, isn't it?
Yeah. Yeah. So InSight, as we remember, is the stationary lander that was intended to study the interior of Mars. We've talked more about InSight because of the sad issues from the mole, which never really...
The long-running saga of the mole.
Which never really got going.
Yeah.
And I think InSight right now is actually still powered down because they had to power down because the solar panels
got dirty
and they didn't have enough sunlight.
They were really crossing their fingers that a good windstorm would come along. And
Percy's been seeing lots of dust devils and windstorms. So where Percy is, it's actually pretty windy, it turns out.
Yeah.
But there was, I need to check actually if InSight's powered back up again. But a bunch of papers just came out from InSight in which is what happens. You take a bunch of data, then you write some papers. That's how we do science, I've heard.
That's what they tell me.
That's what they tell me. But one of the big questions it's trying to answer are things like how big is Mars' core and how big are like the different layers on Mars and how much heat has sort of is coming out of Mars right now.
Right.
So these papers are mostly about how big things are. And it turns out that the lithosphere, so the rocky outer part of Mars, the crusty part, is probably thicker than we thought it was.
So the lithosphere on the Earth is not synonymous with the crust, right?
Yeah, it's always a confusing thing, right? Because crust, mantle, core is based on
dense composition,
right? Composition and density, but not on solidity, and how. All right, so the solid kind of part of the outer Earth is the crust and the top bit of the mantle as well.
And that's the lithosphere.
That's the lithosphere. And
so
then
the lithosphere is thicker. The
lithosphere. Oh, delicious.
Is the crust plus the top part of the mantle.
Right.
Okay.
Right.
Yeah.
And I guess that's thicker on Mars than we expected?
Well, it's thick. It's maybe a little bit thinner than we expected from some estimates from global averages and from orbital measurements. They think it's probably about 72, the crust is about 72 kilometers. Now I'm going to throw
Now
it
you're
back
gonna
to the
mix up
confusing
crust and
mixes.
lithosphere.
Yeah. Let me make sure I say this right then.
Right.
So they think. Go ahead.
No, I was
yeah.
I was just going to fill in.
Oh yeah,
the
while I
awkward
was
pause
checking,
there.
while I was checking my number. Yeah, so they think. Well, I'm going to say they think that the crust is probably about 72 kilometers. And again, this is sort of at the location of InSight, so it could be a little bit thicker other places.
Yeah.
But and one of the things about that is that like this is so one of the big things about Mars is that it doesn't have tectonic plates like we have here on Earth. And that has to do, and if it's got a sort of thick crust, it's like even harder to form those plates. So that kind of makes sense. But they also think that the crust is not as thick and it has a lower density than they predicted, which is kind of interesting. And then they also found that they're measuring the depth of the core, which is around 1,500 kilometers from the surface. So there's a fun little picture that shows like how far down it is. And it's also lower density than they expected.
The core is lower density, but bigger, right?
But bigger than they expected.
Yeah.
Okay, I was going to say, it can't all be lower density or else the whole
Yeah,
planet.
everything is lower
'Cause
density.
we know the mean density of the planet.
Well, the
Yeah.
core is more dense than the mantle.
Right.
And so if the core is bigger.
Right. So if the core, if the core is less dense, but less dense, then it has to be bigger, vice versa.
Yeah,
Right.
and so with such a large core, there's not much room for a mantle, which is
Right.
where you get a lot of that heat trapping that creates more of the fluid flow and stuff like that.
Yeah.
So there is basically like a very simple, probably really thin mantle, but they need a little bit more data to try to figure out to resolve some of it. But we have some basic measurements now.
So how does this? Well, I don't know. Maybe you guys know or don't know. I don't know. How does this work? Like on Earth,
it's one of those.
it's one of those two. You either know or you don't know. I mean, on Earth, this is the way you kind of figure out what's happening in the interior of the Earth. I mean, there's a few ways, but primarily it's earthquakes, right? And so it's having seismometers all over the surface of the Earth and finding out how fast these waves go through in various directions and so forth. But we only have, so now we have InSight.
One
We have one seismometer. How do you, so there are Mars quakes.
So
and
you look for things, right? So one thing that happens with earthquakes and these seismometer networks is if there's an earthquake, it's like a pulse. It's like hitting the Earth with a hammer, and it sends a pressure wave through the solid body of the Earth, and that pressure wave bends and bounces when it hits various boundaries, such as crust, mantle core type boundaries, and then you can piece things.
There's different densities.
Yeah. And so with InSight, you just got the one seismometer, and there are jostlings that happen. There are quakes,
there are Mars
thermal
quakes.
Things that produce these little tiny quakes. And you can't do this 3D localization, but you can maybe see bouncing down and back up.
Right. Yeah.
Also, there's two types of earthquake waves.
P-type and S-type.
Correct. And one of them, the P type, I think, let's make sure I say that right, is the one that changes shape more, which is what you're talking about. And the other ones can like go through different, like they can go through the core. So like based on the timing of when those arrive relative to each other, it gives you information about what it's traveled through. So we use that a lot on Earth, even when we're doing the multi-point locations, to understand like what type of thing it was and what it's gone through. So you use the difference between the arrival times of those two types of waves to say like, oh, well, this is the type of stuff it's gone through, and we can estimate where it came from. But they haven't had a good one, they don't think, from the other side of the planet yet. And that's what would really help them get better details about.
Yeah, because what I was going to say is this: it's hard for me to believe that they can reasonably well. I mean, it's hard enough to model what's happening inside of Earth, even with all the network we have. So with one source of data,
it's worth pointing out though that's not the
backwards.
only observational constraint they have on the interior structure, because you've got the shape, you've got the mass, and you have the mass at a relatively high, sort of the mass distribution from the orbits of things that are close to the. So you have these two moons that are in close. The closer they are, the more sensitive those orbits are to funny distributions of matter within the planet. So we have a bunch of satellites orbiting Mars, and then there are the two natural satellites orbiting Mars that are all close. And you track those orbits very precisely. Those provide constraints on these, what we usually characterize as coefficients of the spherical harmonic expansion of the gravitational field, which is just how lumpy the mass distribution is inside the planet. So what you said, Addie, answered the question I was going to ask, which is because, like, there's a quake. In principle, one of these waves can bounce off the other side of the planet, bounce off the surface, and then come back to you.
Right.
Then it's traveled through everything in between twice. But if it's those quakes are probably too weak, I guess, so far for them to have seen something go all the way through.
Yeah.
Well, let me drop some trivia on you.
Don't hurt us.
It's lightweight.
Okay, good.
Yeah. And it's solar systemal. That means pertaining to the solar system. and then we'll have a extrasolar systemal science, and then some astrophysical pertaining to astrophysics.
That works. That
one's a word.
Pertaining to astrophysics. So it's 3 questions of a theme.
Okay.
It's about naming.
Okay.
Which world has features that are named by the International Astronomical Union for planets from the Dune novels by Frank Herbert?
Ooh.
Your choices are Titan, Saturn's moon Titan, which has dunes.
Does.
Mars, which has dunes. Venus, the moon, or Pluto. One of those objects the International Astronomical Union uses as a theme for naming at least some of the features on that object after planets from the Dune novels by Frank Herbert.
I feel like I'm going to lose some sort of cred here when I get this wrong.
It's okay.
I don't think so.
I lose cred every week.
And then there were 2 follow-ups in the same genre, same vein that I'll give you when you're...
Oh, so it's not also sci-fi? You said genre, so I was...
No, the same vein. I corrected to their naming types.
Okay.
So our other sort of planetary-related thing now takes us out beyond our solar system. We love to talk about exoplanets, don't we?
We do. They're pretty fun.
Yeah.
You know what we don't talk about as much?
What?
Exomoons.
You're so right.
Yeah.
And you know why?
Because they're hard to find.
I haven't really seen them until...
They're small.
Yeah. It's amazing we can see exoplanets.
Yeah.
And we've seen thousands, mostly indirectly, but some of them directly. And the one of these direct detections with this millimeter wave telescope array called ALMA, which I don't know how many years it's been online, but relatively recently, 10-ish, maybe 15 years.
It gives us lots of great exoplanet disk pictures.
It's been doing amazing. The kind of observations that when I was a student I would not have believed.
Yeah, right? Mm-hmm. They're crazy.
Like actually pictures of these things that we always sort of theorized about. So it detected through direct imaging, a protoplanet in a disk around a star called PDS 70. It's a young star, 5 million years old or so, a little bit less massive than the sun, 0.8 times the mass of the sun, at a distance of about 112.4 parsecs from home, which is 350 or so light years away. So not too far away as these things go. We saw PDS 70b, a planet at an orbital radius of 22 astronomical units, so about the distance of Uranus from the sun, that far away. Not entirely sure what the mass is. Then another planet, PDS 70c, at a distance of 34 astronomical units from the star, about Neptune kind of distance. Yeah. Neptune to Pluto sort of distance. And they create a big gap. So we see a picture of the disk, see these planets. Now they can detect that around PDS 70c, there's a disk around that planet.
That's exciting.
That's awesome.
Which is cool.
That's pretty cool.
Yeah, now you've got my attention.
Oh, a new thing.
That is pretty cool. Yeah, that's just like a neat measurement.
Yeah. So let me make sure I said that right. I said PDS 70c.
Yes.
So I think this is cool because...
Okay.
Thank
you.
when you're taking intro astronomy, something like that is always a fascinating question, and not just for intro astronomy. It's like, where do moons come from? Like our moon, we have a big giant moon. That's the moon everybody knows. It wasn't created as like part of a disk around the early forming Earth. It was a result of a
disk around
later
a later
collision.
forming Earth.
That's right. That's right.
Because
or maybe a synesthia.
the early Earth probably did not have enough mass to
Eye rolling.
the early Earth didn't have enough mass to like gather a bunch of stuff around it, like make a mini solar system. Whereas the outer planets, Jupiter and
They took
Saturn,
all the mass.
yeah, they're really massive things, and they make like little mini solar systems around them as they're forming.
Right.
And that's where like the Galilean moons of Jupiter and so forth come from. And so this is the reason this is awesome is like when you're thinking about the theory of how our solar system came to be, you have to think of ways to test that in order to make it a good scientific theory hypothesis. And one of the ways is to see if things in other solar systems are doing the things that we predict. And it looks like they are. That's
nice.
That's awesome.
That is awesome.
The whole story of satellite formation is more complicated than we let on in intro astronomy. Not just the moon stuff, but the Galilean satellites, but the other systems. There's some funny aspects of them that require some sophisticated aspects of the model. It all basically has to do with how you've got a planet in a disk around the star, and that planet interacts with that disk and it carves out a gap. Mm-hmm. But then material has to get to that planet to feed the disk around the planet, from which you make moons.
Right.
And so there's this complicated, semi-particle, semi-fluid physics problem going on with these feeding zones of gas and dust coming in from the disk across that gap and into the zone around the planet. In this particular study, they said, okay, well, if we take a look at this disk around the planet, if we assume it's either sort of micron to millimeter size grains, they get a mass of the disk of about 1/100th of the mass of the Earth, which is right in the sort of ballpark for, decent sized moons.
Good moon.
Right.
Yeah.
That's
good sized
exciting.
moons. And they have they are also able to say what the sort of mass formation rate of the planets is. The star is quite young. This is protoplanetary disk, so these things are still in the process of forming, which is also amazing.
They're still baby planets.
So they think, or they arrive at an accretion for those two planets of about 10 to the minus 8 Jupiter masses per year, which sounds like a super small number, but that means in 100 million years, that's a Jupiter mass.
Right.
And,
No time at all.
and a Jupiter mass is a big mass.
Yeah.
Right.
So for a planet.
And it won't, there's not enough material for it to ever get that big
It's
either.
probably,
though,
these are not going to, but still, it's cool.
Yeah.
We're seeing the stuff.
And it's cool to see the difference between the
actually seeing it. It's not just like inferred from some weird spectral thing.
Right. This is not just the output of a computer model. This is the real thing.
And between the planet that has this disk and the planet that doesn't have this disk. So it's cool to see those in action.
Yeah. So that takes us out into the galaxy. And now
we're in Jim's realm.
For Jim's attention there.
No, I'm very fascinated. I mean, I love, one of the great things about this podcast for me is I learn all this stuff about the small scale things in our solar system. And I'm very fascinated. Only thing I wasn't caring about
It's the helicopter.
Was the stupid helicopter. Actually, I loved the helicopter when we first flew it. I loved it as a proof of concept thing. You fly it a few times, it works great. Okay. Give it up.
That's why you can't have nice things, Jim. You just get bored with them.
I get bored with them. Well, but yeah, the other two things are very cool. But this is also pretty cool. This was the cow. We've talked about the cow. This is just basically an update.
I do remember talking about the cow.
Yeah.
But I don't remember what it was.
I don't know what we talked about before.
We did talk about the cow.
We talked about the cow as an example.
There was like a new thing that was like a cow.
Yeah. Yeah. There had been some new in 2018, 2019. The cow is a the cow is an FBOT. An FBOT. It was a fast blue optical transient. So it's this really bright explosion, like a supernova.
That's what FBOT stands for. Got it.
Yeah, fast, bright.
Yeah.
Fast blue. Sorry, optical transient.
Nice.
Transient because it's a very it gets bright and then dim. And it does that very quickly, more quickly than a typical supernova, and it gets brighter than a typical supernova. So it's maybe 10 or 100 times the what's the word I'm looking for? Brightness. Luminosity of a typical supernova, but it ramps up and it ramps down quite quickly, and so we don't really know. It's just like a new category of astrophysical phenomena that we're not really sure we understand what is happening with it. So there's the COW, which is short for like Supernova 2018 COW, COW. It just happened to have that funny name, so we call it the COW. And then there have been a few, like I said, a handful of other of these things recently. But this is this paper that just recently came out was a more careful look at that particular incident.
Yeah.
And looking at the X-rays that are coming from it with very fine time resolution. So looking at how the X-ray emission from this thing changes over time, but on very, very short time scales. And what they found, a very interesting thing, that there was a kind of periodicity to the brightness of the X-rays of something like 250 hertz.
Oh, wow.
So that's a pretty fast pulsing of X-rays. And what that does for you is gives you some really neat clues about what could possibly be responsible for this phenomenon, because there have been a whole bunch of models about what could be producing these FBOT things, like what kind of, because they don't match, like, the two typical supernovas that we talk about in astronomy are the massive star supernova, right, and the white dwarf supernova. They're
what you're going to see pretty much.
Right. They're well modeled and they match the data very well. But this kind of supernova is just a different thing, and so there's been a lot of models about what it could be, but these recent observations or recent analysis of the data rules out a bunch of those possibilities. It basically has to be some compact object in there powering this thing. And so it's got to be a black hole or a neutron star that is in this thing. So basically, there are plenty of other models where it's just like stuff that blows off and then plows into like a really thick interstellar medium or something like that. But it just can't be that, because that wouldn't produce this oscillating signal. So the oscillating signal would come from something rotating very quickly, something like that,
magnetic field,
right,
pulsar-ish,
right,
sort of thing,
right. So this is something like, and how quickly it pulses back and forth also limits the size of the thing based on causality arguments, right? The faster signals change, the smaller the object has to be that's producing that,
right?
And so we thought at one of the other models was it's a really big, like 10 to the 4, 10 to the 5 solar mass black hole. It can't be that. The size of that would be too large for this, and so it's got to be a small thing, like a stellar mass kind of black hole or a neutron star that's left over after maybe. So I think the best model now is one of these failed supernova things where.
So how do you have a failed supernova?
It just doesn't work.
Well, I fail at so many things that I know it well.
It's
Josh can't comprehend
that you can
this.
never pull off a supernova at all.
Yeah. It just doesn't work.
So. But I'm actually asking, what's a failed supernova?
What is a failed supernova? Well, it's just, I don't know. I mean, it's...
Okay. That's not a very satisfying
it's just, and I think we talked about this in a previous... It's like...
When a star starts to, looks like it's going to go supernova, so it brightens, but then it doesn't ever do the big,
Well, and so because in a supernova, you blow all this material off into space. But if I form a black hole too soon, kind of, if the black hole forms before the kind of explosion goes, then the material falls in instead of falls instead of going out. So
it still makes a black hole, but it just doesn't supernova.
Okay.
Right.
Okay.
It doesn't really make a nice big show of it.
Okay.
So
it's
anyway,
a discrete supernova is what I would call it. I wouldn't call that a failed supernova. I would call that
discrete.
A modest supernova.
A modest supernova.
Yeah, sure.
It's not a showy supernova, just a very soft-spoken supernova.
Yeah.
Okay.
Failed.
Because when you say failed supernova, it makes me think like
the star is still there or something. Yeah.
Like the star didn't die. I'm like, well, that's just not. It's not a failed supernova. That's just like nothing. Whatever.
Nothing happened.
Okay,
but it does happen. It still forms a black hole.
I got it. Okay. So there's
they have sometimes misleadingly been
probably
called
a black hole in there.
unnovae.
And it's brighter than what was going on than other supernova because it's not really a supernova. So what produced this fast?
What did it?
There's just still a lot of questions about this. We don't have the answers.
So we just ruled out some things.
We just ruled out some things.
Ruled out it's
We
not
like
a very
doing
big
that.
black hole.
Right.
Okay.
And so the mechanics of what's actually producing all of the light is still something we're wondering about. Like it's different. It's definitely different from a supernova. The shape, like I said, the how quickly it ramps up, and also the spectrum of stuff. It's bright in different parts of the electromagnetic spectrum. It's weird. We don't understand it well, but at least we've started to rule out some of the possibilities that we had when we first saw these things.
All right. We'll have to keep checking in with the cow.
Every time we hear a cow update, we'll let you know.
Okay.
Ooh. We
Which
should have a mooing sound.
which
for the cow
object
updates.
in our solar system
Oh yeah.
has features named by the International Astronomical Union after planets from the Dune novels by Frank Herbert? Is it A, Titan, B, Mars, C, Venus, D, the Moon, or E, Pluto?
I think it's Pluto.
I'm also going with Pluto. I feel like we should know this, but I'm not. I don't. But I'm going to say Pluto as well. That was what I was going to go with.
It's actually Titan.
Is it Titan? I knew they were all named. I knew about like the Mare and stuff like that.
Pluto is very underworld themed.
Yeah.
It's all sort of underworld features and
Right.
gods
Yeah,
and
that's
things
right.
like that.
That makes sense.
What? Give me an example for Titan. I can just, for some reason, all I could think of was the Mare on Titan.
Well, Arrakis is the main planet in Dune, so I'm guessing that there's something on Titan named Arrakis.
Yeah.
Okay, your follow-ups following the same general idea. Which object or system of objects has names that are characters from the works of William Shakespeare and Alexander Pope, who are, by the way, the first and second most quoted authors
Uranus.
in the Oxford Dictionary of Quotations? Is it A, Triton, Neptune's moon, B, Callisto, moon of Jupiter, C, Mars, D, the moons of Uranus, or E, the moons of Neptune?
I'm going to go the moons of Uranus.
I'm going to go with Eddie.
Yeah, you're right.
I knew that one.
Okay. And then finally, mythological names associated with creation is the theme for the names of which of the following? QB10s, that's classical trans-Neptunian objects named after QB1, the first Kuiper Belt object discovered. Near-Earth objects.
QB is named after the Kuiper Belt?
1992 QB1.
Oh, I see.
Just, Q.
How do you alphabet?
They do
I get it.
every.
Yeah, I got it.
That's just the standard sort of asteroid naming scheme or comet naming scheme. Anyway, the classical Kuiper Belt objects, basically, near-Earth objects, Trojan asteroids, features on Venus or Plutinos.
What was the first part of the question?
Which of these Plutinos, by the way, just so I can finish, are Kuiper Belt objects in the same sort of dynamical orbit as Pluto?
Yes.
3-2 resonance with Neptune.
Plutinos. It's also the name of my Italian restaurant. Plutinos.
Which of those is a naming scheme following mythological names associated with creation?
With creation.
Mythological
Say the
names
options
associated with creation. QB10s,
Okay.
near-Earth objects,
Okay.
Trojans, Venus, or Plutinos.
QB10s.
Venus.
It's QB10s.
Nice. I didn't think it was Venus. I thought maybe Venus because
Venus, I know.
Yeah, that was good.
Yes.
That was a good psych.
Good psych out.
Yeah.
Yeah.
The juking.
Let's see. I had another sort of follow-up Dune question for you. Is Dune in a future? Is Dune in our future, or is Dune in a Star Wars setting, distant? A non-related
Galaxy far, far away?
non-related to people.
That's a good question that I don't know the answer to.
Yep.
I'm going to say a Star Wars one.
Yes.
Have you read Dune, Addie? Methinks
I have not read Dune.
thou hast not.
I have seen the 1984 movie, Dune. I have not read Dune.
It's a good book. Yeah.
I
Dune, but
have
it was a
been
long
to
time
some
ago.
dunes.
It is actually supposedly in our future, like 20,000 years in our
Yeah,
future.
I was thinking that.
Okay.
Which it feels very much like so disconnected from.
Right.
There's no mention of Earth
Right.
or
Yeah,
anything
yeah.
like that in there.
Some of the things on
in it.
Titan, the Colles, Colles, are small hills or knobs named after characters in Tolkien's Middle Earth.
I didn't say that would be. I didn't say the.
No, yeah, I'm just looking at the list still.
Yeah. Okay.
That's cute.
Well, while it may have felt like the time to accelerate
Time's
to
all over the place.
1/10 the speed of light with an ion drive, it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you free distracting edutainment for your commute. Be sure to follow us on Facebook and Instagram to get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter.
At walk_the_galaxy.
Ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Production assistance provided by Diego Rodriguez. Thanks to our listeners in Mississippi and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquarks signing off until the next episode of Walkabout the Galaxy.
Plutinos.